Now that we're done with LCI, we move on to Life Cycle Impact Assessment, or LCIA. LCIA is the phase of an LCA which is aimed at understanding and evaluating the magnitude and significance of the potential environmental impacts for a product system throughout the life cycle of the product. So we're going to take a look at the overview of the different processes that happen inside LCIA using this small example. So we start off exactly where we stopped. So we have the LCI results. So these can be sulfur dioxide or hydrogen chloride emissions coming from your product system. This can be computed, example, as kilograms per functional unit of your product. And so given this LCI result, you then go into the main part of the LCIA. So firstly, you use your LCI results and you assign them to an impact category. So for example, sulfur dioxide and hydrogen chloride can be assigned to impact category of acidification. So once you have assigned these gases to this impact category, you use a characterization model that gives you a category indicator for your impacts. So essentially what this means is something that indicates that this emission has happened or the effect on the environment. So in this example, a proton release of, in this case, H+ aqueous ions into the atmosphere is correlated with acidification. So given this category indicator, we assign some environmental relevance, and this basically gives us your category endpoint. So essentially where this negative effect is happening. And this can be forests, vegetation, and so on. Looking at the Mashar example, here are 4 selective impact categories that we looked at. So these are acidification, global warming, ozone depletion, and water intake. So you can see the reference units for each of these categories. So for acidification, like you said in the previous example, it's H+ mmol equivalents. Global warming is grams of CO2 equivalents, and ozone depletion is CFC equivalents, and water intake is just simply liters. So you see some figures there for the mushroom substrate bag and the Mashar reusable pods. So in general, because the reusable pods require more material and different mechanisms for production, they have a larger initial impact for the same volume of functional unit. For example, if you look at global warming, you have 102.46 grams of CO2 equivalents for the substrate bag, but 217 for the reusable substrate pods. The point here is that the reusable pods are reusable, which means that you can compute how many reuse cycles does it take for the Mashar pods to be more sustainable or have a lower impact than the substrate bag. So we have this other column here that shows exactly how many of these reuse cycles it takes for the Mashar pods to reach the break-even point. So in the case of global warming, it's around 2.1 times. So as long as you reuse the bucket at least 3 times, you would already have had lower impact than you would have had with a non-reusable substrate bag. Similarly, you can see the figures for other categories.